Let us talk about Composable CDP today, what it is, how it works, and how to implement it on Snowflake. Before diving into Composable CDP, let us first create a picture of a brand and understand how we can solve some of its problems. The brand we are discussing today is Lumio, a fast fashion company operating across Southeast Asia. They are headquartered in Singapore with more than 200 stores across the region, and they sell through both online and offline channels. This makes them an omni-channel brand, with a specialty in offering trendy and affordable fashion, particularly modern denim and casual wear. Now, what challenges would a company like Lumio face? Broadly, there are three categories of challenges: data challenges, marketing challenges, and growth-related challenges. For data challenges, the first problem is fragmented profiles, because customers shop online and offline, and their data is captured separately without being unified. The second challenge is the identity gap, meaning there is no single customer profile, which we will discuss later. The third is underutilized machine learning, as data is not consolidated in one place, and there are not enough attributes for each customer to apply machine learning algorithms efficiently. Moving on to marketing challenges, the first problem is lack of personalization, since machine learning is not being used effectively. The second issue is inconsistent customer journeys, with multiple teams across the brand launching campaigns at their own pace and making separate decisions. The third is slow activation, caused by delayed insights and slow experimentation, which makes campaign activation equally slow. Finally, for growth-related challenges, the first issue is ROI blind spots, where conversions and engagement cannot be properly attributed to the right channels. The second is data overload, with massive volumes of data coming in daily. The third is compliance pressure. So for a brand like Lumio, the underlying issue is fragmented systems, which lead to fragmented experiences for its customers. And this is where ADA can step in, by implementing Composable CDP to solve these challenges. So how do we do it? We place Snowflake at the center of the architecture and use it as a data warehouse, allowing us to ingest all kinds of data, both batch and real-time, through ADA partners like Fivetran and MetaRotor. Once the data is inside Snowflake, we can clean it, transform it, and create hundreds of attributes for each customer. After building these single customer profiles in Snowflake, there are three key options available. The first is data analytics and reporting. The second is applying machine learning and AI for personalization. And the third is customer segmentation for marketing activations. With segmentation, we can create customer groups and export them into CRM, CDP, or MIT channels, such as Braze for email, SMS, WhatsApp, and other activations. We highlight Braze here since it is also an ADA partner, but in reality, we can leverage any existing CRM channels that Lumio or its customers are already using. Let's deep dive into some of the challenges we discussed 2 slides ago. The first is identity resolution with Neo4j. This is important because, as we've just seen, customer data is highly fragmented. The second challenge is building a customer 360 in Snowflake. Even if the data is centralized, we still need to create hundreds of derived and third-party attributes, without which we can't fully understand the customer. The third challenge is leveraging machine learning capabilities for customer segmentation, since we need advanced algorithms to gain deeper insights from customers. The fourth is AI-powered applications for segmentation, without which experimentation and targeting cannot be executed quickly. So how can a CDP solve these challenges? Before we get there, let's build a picture of one of Lumio's customers, a persona we'll call Tanya. Tanya has been a customer of Lumio for some time. She follows Singapore fashion influencers, is inspired by K-pop and local events, and shops both online and in-store. For a customer like Tanya, what challenges arise? When Tanya visits the website, clicks on products, browses items, and adds them to her cart, that data is collected in one data source. Then when she goes to the mobile app and repeats similar actions, the data is stored in a different source. Finally, when Tanya visits a physical store and makes purchases, that data is recorded separately again. Now, we also have additional data points captured at the retail store. such as her preferred store, staff interactions, and engagement in in-store activities. On top of that, we have her data coming in from CRM channels, which includes campaign-related insights that show us what kind of campaigns she prefers, which channels she responds to, and how often. Finally, we also have her profile details, typically stored in a relational database like Snowflake, where we maintain her demographic information, churn scores, preferences, and more. The challenge here is that all these data points exist across different systems. Website data is usually captured in GA or Adobe. App data is stored elsewhere, while campaign details sit in CRM or CDP platforms. This fragmentation leads us to the first challenge, ID resolution. The process of integrating all these data sources into a single place to create a unified customer profile. Let's look at the challenge. Tanya's first journey begins through Google Ads. She comes via Google, lands on Lumeo's website, and we can see her cookie ID captured here. Since she did not log in, her email ID and phone number are not collected. In a second journey, she comes through Facebook, installs the app, and now we have her mobile ID, user ID, and email as well. However, these two journeys are still not connected, so we cannot confirm they belong to the same person. In a third journey, Tanya visits through the TikTok web browser where her cookie ID and Lumio user ID are captured. While the user ID matches the previous record, the cookie ID is different, meaning the channels and devices are still not fully linked. Then comes a fourth journey via an email campaign where she clicks a Braze campaign, lands on the website, and places an order. To complete the purchase, she provides her phone number, email, and user ID. Since this is done on the same browser as Journey 1, we are able to match the records. Finally, in the fifth journey, Tanya makes an offline purchase where only her phone number and name are captured. Notably, her name is recorded only in this specific journey. What ID resolution does is create one consolidated profile for Tanya. We generate a single identifier called a unified ID, or a persistent ID, and all other IDs are matched and mapped to this unified ID. As a result, we can now recognize Tanya across all her identifiers. For example, the web cookie IDs C123 and C456 both belong to Tanya. We also know her name, phone number, and email. Even if she has 2 emails and 3 phone numbers, that is acceptable. Everything is still mapped to Tanya's unified ID. We will now quickly see a demo video in Neo4j, where we walk through how a typical Neo4j map looks for multiple customers, followed by a deep dive into how Tanya's journey specifically appears in the service.
We saw how Lumeo's diverse data sources are collected and centralized in Snowflake. Before we can proceed to unify the customer profiles, we must solve a key challenge. Customers often have multiple identities across touchpoints. To address this, we build an identity graph in Neo4j. The process starts with clean data in Snowflake containing user data without a single unified customer identifier, which is modeled as entities, relationships, and exported into Neo4j. In Neo4j, fragmented identifiers, cookies, sessions, emails, phone numbers are linked across Lumeo's touchpoints. We can see a sample entity relationship graph for customers of Lumio, showing how various customer identifiers are stitched together. Now let's zoom in on Tanya's identity graph. We observe blue nodes, traffic and campaign sources, Google, TikTok, Facebook, Braze. Orange nodes, browser cookies. Light blue nodes, web and app sessions. Yellow nodes, Tanya's identifiers, user ID, email, phone number. Other nodes, campaign sources, tickets and products linked to her orders. From this, Tanya's journey with Lumio becomes clear. She arrives via sources like Google, TikTok, and Facebook. Some sessions are anonymous via cookies, while others are tied directly to her login and campaign engagement. As Tanya engages, placing orders, raising tickets, receiving campaigns, Neo4j connects these activities through shared identifiers. Through identity resolution, all her fragmented activities are stitched into a single persistent person ID, the large green node. This person ID becomes the golden thread that unifies her journey, enabling Lumio to recognize her consistently and deliver personalized experiences. The resolved data is then ingested back into Snowflake, enriching Tanya's records with the person ID for a complete cross-platform view. This identity resolution process establishes the foundation for rich, unified profiles in the gold layer, powering advanced segmentation, personalization, and activation at scale.
So now we have seen ID resolution in Neo4j, but why does it matter? Why should we do it? The first reason is that customers use multiple devices and often switch between different browsers when shopping. So we need to unify customer touchpoints across web, app, and store. The second reason is that only when all data points are brought together in one place can we deliver truly personalized experiences. The third reason is privacy. Customers may set a specific privacy preference in one channel, and that same preference must be applied across all other channels to stay compliant. The fourth reason is that third-party cookies are disappearing, so we need to generate as many first-party data points as possible and use them in the most effective and efficient way. Now that we have completed the first challenge, we move on to the second challenge, which is creating the Customer 360. With ID resolution, we gathered all the data in one place and built a single customer profile, but we still need to enrich that data to enable personalization at scale. This is how a holistic profile of any customer looks. In Tanya's case, we can see 8 distinct categories into which the data points are organized. Under each category, we can generate multiple data points. This is highly customizable for each vertical. The buckets will look different for retail, different for CPG, and again, different for BFSI, pharma, and so on. In reality, ADA will create between 100 and 400 data points for each customer, depending on the vertical. So we will have a quick demo to understand and see how these data points appear in Snowflake.
In our previous demo, we explored how identity resolution in Snowflake and Neo4j unified fragmented customer identifiers across touchpoints, creating a persistent and unique person ID. This became the foundation for building a complete view of each customer. Building on that, we now introduce the unified Customer 360 gold layer in Snowflake. Implemented as a single table named Lumio C360 in the gold layer, it consolidates all cleaned and resolved customer data into one profile per customer. In this table, each record uniquely corresponds to a customer, and each column represents an attribute that deepens Lumio's understanding about the customer. The persistent person ID generated from identity resolution process is also included, ensuring every customer is consistently identifiable across datasets. The Customer 360 gold layer contains multiple fields as columns that captures a wide spectrum of attributes, including demographic attributes such as city, gender, and age group. Enriched attributes derived from ADA's exact service are also included in the Customer 360 gold layer, adding additional context such as app usage persona, affluence, and places of interest. Behavioral attributes across multiple dimensions. Transactional behavior. Attributes such as average order value, preferred product category, etc. Web and app usage behavior. Attributes such as number of sessions and page visits, etc. Engagement behavior. Attributes such as campaign engagement rate, email open rate, etc. A key advantage of Snowflake is its data lineage feature, which makes it possible to trace how the gold layer is built. The gold C360 table flows from its staging and enriched gold tables, which in turn are derived from cleaned silver layer tables, which ultimately source data from the raw bronze layer. This lineage provides governance, transparency, and trust in how customer profiles are generated. In conclusion, the unified Customer 360 gold layer in Snowflake is Lumio's single source of truth on the customer, combining demographic, behavioral, and enriched attributes to power smarter segmentation, deeper personalization, and scalable customer engagement that drives ROI and growth.
Now with the video, we have seen and understood how the Customer 360 will look, which can be leveraged for reporting, analytics, and machine learning. Next, we will explore how machine learning can help us utilize these data points more effectively. A DA has the capability to implement machine learning algorithms directly on the data. For example, the first use case is customer segmentation, which helps us identify and understand different customer personas. The second is personalized recommendations, including product suggestions. Next, we have churn and retention modeling, along with CLTV analysis. Following that, we cover ROI, or attribution and channel level optimization. We also have campaign engagement analytics, which leans more toward reporting. And finally, we introduce the AI Marketing Assistant, a next-generation tool that we will discuss later. To demonstrate, we will quickly show how we implemented RFM segmentation on Snowflake. Since Snowflake supports Snowpark, we don't need to rely on external services for machine learning. It can all be executed within Snowflake itself.
Previous demo, we explored the Customer 360 Gold layer in Snowflake, which unified customer data across touchpoints. Building on that, we now apply RFM segmentation and K-means clustering to better understand customer behavior and group them into actionable cohorts for targeted campaigns. First, we load the 100K customer profiles of Loomio into the analysis notebook and examine their recency, frequency, and monetary RFM values. On exploratory data analysis, few customers show unusually high recency or frequency, so we cap values at the 99th percentile to remove outliers and create cleaner, more representative data. With this refined dataset, we apply K-means clustering. Using the elbow method, we find that 4 clusters provide the best separation. We then visualize the results in a 3D scatter plot across recency, frequency, and monetary value that shows yellow, high-value champions, recent, frequent, high-spend green, moderately engaged, good spend, slightly older recency, blue, low frequency, low spend, likely inactive, red, minimal engagement, least valuable. We then validate these clusters against standard RFM segments. Champions, loyal customers, potential loyalists form the high-value core for retention. Lost, hibernating, promising, about to sleep represent reactivation opportunities. Next, we examine how RFM segments distribute within each cluster. Cluster 1, 100% champions, highest value group. Cluster 2, mix of loyal customers and potential loyalists. Cluster 3, largely promising customers, high future potential. Cluster 0, mostly about to sleep, at churn risk. Finally, looking at our anchor customer Tanya Amalia, her RFM scores place her in Cluster 3, promising. She shows good engagement and spend, but hasn't yet reached the loyalist or champion tier, making her an ideal candidate for nurturing campaigns. By combining RFM analysis with K-means clustering in Snowflake, Loomio turns unified Customer 360 data into actionable cohorts, enabling marketers to personalize engagement at scale, retain and reactivate customers, and deliver the right message at the right time.
Now that we have completed customer segmentation using machine learning, let us look at the AI-powered application that ADA has developed for segmentation. What we have done is created a Streamlit application and connected it to the Snowflake dataset you saw earlier in the videos. This application links directly to the Customer 360 tables, learns from the context, and provides answers to the questions that the user or customer may ask about the data. This enables faster experimentation and quicker marketing decisions. We will now see in this video how the application works in practice.
In our previous demo, we explored how Loomio leveraged RFM segmentation and clustering to better understand customer behavior and identify actionable groups of customers. Now, while marketers usually know which segments they want to target, they often depend on data analysts to analyze the data, estimate segment sizes, and measure engagement. This dependency slows down execution. That's where an AI-powered marketing assistant can make a real difference. With natural language queries, marketers can directly interact with Customer 360 and campaign data, explore new segments, and validate performance, without waiting for analyst support. In this demo, we'll showcase how Loomio's marketers can use the AI marketing assistant, built with Snowflake Cortex Analyst, LangChain, and Streamlit. On the left panel, marketers can quickly access Customer 360 attributes like demographics, contact, and channel orders for segmentation. They can also view predefined segments such as discount seekers or churn risk customers. And at the bottom, there's a chat interface to directly interact with the AI assistant. Now let's walk through an example. A marketer is planning a campaign to clear overstocked female jeans. The marketer asks the assistant to design a segment optimized for high conversion. The assistant suggests the following filters. Cluster equals promising based on RFM analysis, gender equals female, and most preferred product category equals jeans. The assistant then identifies 1,200 customers who satisfy these criteria. Next, the marketer wants to understand which marketing engagement metrics can further refine this segment. The assistant suggests options like app session duration, app engagement time, and email campaign engagement rate, and recommends the email engagement rate as the most impactful KPI. The marketer then chooses email campaign engagement rate and asks for a histogram analysis. The assistant generates the chart and observes that most customers show medium engagement, but there's a valuable, highly engaged tail. The recommendation: use a 40% threshold. Following this, the marketer applies the 40% threshold and adds one more condition: customers with more than 5 visiting sessions in the last 30 days. Now the assistant narrows the audience to 550 customers and further identifies 223 of them as highly active with more than 5 sessions last month. Finally, the marketer requests the segment rules, and the assistant provides ready-to-apply conditions. RFM cluster equals promising, gender equals female, preferred category equals jeans, campaign engagement at least 40%, and number of sessions at least 5. This segment can now be created and directly activated in Braze with, say, an email campaign, which we'll explore in the next demo. In conclusion, the AI marketing assistant empowers marketers to move faster, validate ideas instantly, and translate insights directly into activation, bridging the gap from Customer 360 to segmentation and campaign execution.
So now that we have solved all the challenges we discussed at the beginning, what are the key takeaways and conclusions? The first is ID resolution. We implemented ID resolution through the Neo4j service, which enables the creation of a single customer profile. The second is Customer 360, where we learned that ADA has templatized C360 enablers capable of taking data and generating hundreds of customer attributes depending on the client vertical. The third is advanced analytics capabilities, where we saw an example of customer segmentation implemented using k-means clustering. Finally, we have the AI assistant, where we expose data to AI agents that help answer questions and support rapid experimentation. Because of all these components, we can implement personalization at scale. We not only create customer segments, but also have the capability to export them to any CRM, CDP, or MIT channels like Braze, Salesforce, and others.